Hi, everybody. In this lesson, we do our last probability experience. This is the last lesson in which we play around with probability. And we'll move on to our last unit on statistics after this lesson. So here we go. When a car is bought to a repair shop for a service, the probability that it will need the transmission fluid replaced is 38. The probability it needs brake pads is 28. And the probability it will need both transmission and brake pads is 16. So this is a clear Venn diagram here. We've got transmission, we've got brakes, and in the middle, I can put that 16% of both of them occurring. But remember, I can't put the transmission fluid in this circle. I know this entire circle here is 38. I know this entire circle here, the brake circle, is 28. We have to use subtraction to find those gibbous moons there. We have to use subtraction to figure out how big that gibbous is. So 38 minus 16 gives me 22, and 28 minus 16 gives me 12. So now there's one last thing I have to figure out is my outsiders, and I do that by adding everybody up in the middle. I get 0.5. I used up 0.5 here, so what's left over is 0.5 is left over for the outsiders. So 0.50 to make it consistent. So find the probability that a randomly selected car needs transmission fluid or the brake. So the probability I need transmission fluid or the brake pads replaced. Well, what am I adding up here? I'm adding up 0.22 plus 0.16 plus 0.12. I'm adding up or. Or means I'm in one of these circles. I'm in one of these circles and I end up getting, well, I added those up already and I got 0.50. So the OR probability we get by adding these middle three pieces up. Let's come up with a rule, though, for dealing with the probability of A union B, the OR formula. How do I find OR quickly? So here's what we're going to do. It'd be really easy to just add A plus B, right? Just add those two circles together. But look what happened. If I just did the probability of A or B, if I just added them together, there's a problem. What is that problem? If I was in class, I'd ask you right now, but we're not in class. So hopefully you said, well, coach, look what you did. Look what you did there, coach. You added that middleman twice. You added that and probability 2 times. You double counted. I double counted this section. I double counted here. So what we're going to do in our formula is subtract away the intersection. So when you do your homework and see OR problems, you're going to use this OR formula. The probability of A or B, OR equals the sum. You add the two whole circles together, and then you subtract away the and. The probability of A or B is A plus B minus and. OR equals A plus B minus and. It saves us time, and we don't have to go through and make an entire Venn diagram out of these problems. So when a call is received at an airline's call center, the probability it comes from abroad is 32%, and the probability that it is to make change to an existing reservations is 38%. So I have two events here. Suppose the probability that the call is both from abroad is 15%. Calculate the probability that the call is either abroad or to make a change. So I want to know the probability of abroad or change. Well, it's really easy to do now that I have that OR formula. I don't even need to go through and make a Venn diagram. All I need to do is say it's add them together, abroad plus change, minus the intersection, or equals A plus B minus my and. Now, you don't have to use this formula. You could have gone through and made a Venn diagram like we've been doing, but look how fast this is. I'm already done with the question. Or equals A plus B minus and I get 55%. That's it. Or equals A plus B minus and. Are these events independent? Well, how do I test for independence? Well, I find the product. I do A times C in this case. So 32 times 38. What does that give me? 32 times 38 gives me 0.1216. Sorry, 0.1216. So are they independent? Well, does that equal P of A and C? Does that equal my AND probability? No, my AND probability here was 15. So they are not independent events. They are not independent. Why? Their product did not give me the AND probability. The product of the two circles did not give me the AND probability from occurring. So suppose we didn't know the probability of occurring was 15, but we're told they were independent instead. So this time I was told independence. I was given that information of independent events. So what that means is we know our AND probability. The probability of A and C is their product, 0.1216. Now what's the OR formula? What's the probability that the call is either from abroad or to change? So the OR formula, A or C equals, well, what does it equal? A plus the other one minus the AND. In this case, I use their product as the AND because I was told they were independent. So using this OR formula saves you a bunch of time of not having to make Venn diagrams and going through all those steps. So now I get my OR probability is 0.5784. 0.5784. So we can use the OR rule. We can test for independence by finding the product and seeing if it equals the intersection. But here they told me they were independent, so I use that product as the intersection. Couple more and we're done. So on my way to work, Mr. Hines passes through two intersections with traffic signals. The probability he must stop at the first is 40%. The probability of the first is 40%. The probability I stop at the second, that's probably 5 corners, is 50%. I hate 5 corners. The probability he stops at least one light on the way to work is 0.60. Well, at least one means I stopped at the first or I stopped at the second. That's at least one is my OR probability. So first or second is 0.60. What's the probability I stop at both? What's the probability I stop at both? Well, it's an OR problem. OR equals the first plus the second minus AND. Well, that's what I'm trying to find. I'm trying to find the AND probability. So it just becomes a plug-in algebra problem. 60 equals 40 plus 50 minus AND. OR equals first plus second minus AND. 0.60 equals 0.90 minus the AND. I'm going to subtract 0.90. Get negative 0.30 equals negative AND. So the AND probability is clearly 30%. The first and second is 30. So I was given an OR problem and had to find the AND probability by using the OR formula. OR equals A plus B minus the intersection. And I found the intersection is 0.30. What's the probability I don't have to stop at any traffic lights? So that's not the first and not the second. So this is the outsiders here, right? The outsiders is actually the complement of OR. The complement of OR. So the probability of not the first and not the second. I don't want to stop at any lights here. So on a Venn diagram, I want to know what are my outsiders here. So I know OR is 60, so it's 1 minus 60. 0.40 is my outsiders. If I don't want to stop at any lights, I have to live on the outside. And the outside is the complement of OR. Are they independent? Well, let's find their product. 40 times 50. 40 times 50 is 0.20. 0.20 does not equal AND. Does not equal my AND probability. So are they independent? They are not independent. They are dependent events. They are not independent because 0.20 does not equal the and probability we calculated. Last one, and the last one's kind of brings us back to some 7th grade health here with typhoid. So a typhoid Mary here. A traveler, we'll call her Mary, estimates that for an upcoming trip, the probability of catching malaria is 18%. That sounds like a great trip to go on. There's only an 18% chance you get malaria. Oh, and then a 13% chance that you get typhoid. Lovely. The probability you get neither of these diseases is 75. So what did they tell us there? They told us, so here's my malaria circle, there's my typhoid circle. The outsiders is 75. So if the outsiders are 75, what's my or probability? Well, the outside is 75, so the insiders, the or, is the complement of that, 25%. I'll say that again because there is a WebWork question just like this. My outsiders is 75%, so my or probability is the complement of that. That's what my insiders have to be. My insiders have to be 25%. What's the probability that I'm lucky and catch both diseases? Well, or equals malaria plus typhoid minus and. 25% equals 18 plus 13 minus the and probability. 25 equals, let's see what we get here. We get 31. Well, what minus 31 minus what gives me 25? That gives me an and probability of 0.06. The probability of malaria and typhoid is 0.06. That's lovely. There's a 6% chance that I come back from this trip with both malaria and typhoid. Are the events catching malaria and catching typhoid independent? So let's find the product. Malaria times typhoid. P of M times P of T. The product of malaria and typhoid. Does that give me the intersection? Does that give me the intersection? Well, if they were independent, I would have 0.0234. I actually have a 6%. We know the probability of M and T is 6%, so they are not independent because these two numbers are not equal. So they are not independent. What a lovely problem that you're getting typhoid and malaria. And there's a 25% chance you're getting one of them. 6% chance you're getting both. So that's it for probability, guys. I will see you in the next video, which will actually be about probability again, but be in more of a statistics setting. See you guys.